Welcome everybody to the OpenSim webinar. Hope you're having an excellent day. My name is Scott Delp. I'm a professor in bioengineering and mechanical engineering at Stanford University, and I'll be moderating the session today. Jen Hicks will be the presenter. Jen is the OpenSim Research and Development Manager and has played a lead role in developing OpenSim software and interacting with users. And she'll be the main presenter here for introducing OpenSim 3.0. This is a big day for us. We introduced OpenSim 1.0 at the conference of the American Society of Biomechanics back in 2007. And since then, the response has really been quite satisfying. There are now thousands of people using OpenSim and contributing models and simulation results. And we hope to continue that momentum with lots of new and exciting features that you'll see in the 3.0 release. The goal of our webinar series is to showcase research and insights on OpenSim and to communicate with our growing and geographically diverse set of users. We'd also like to promote discussion and community building. We'll do that through a number of different things, including this webinar series. Just a few technical reminders. You can submit questions, and we encourage you to do that via the text-based Q&A panel on the software you're using on WebEx, the software you're using to participate. And you can get more information on the participating on OpenSim webinars that's available at the OpenSim website. So with that, I want to thank Jen Hicks for being here this morning. As I mentioned, Jen is the OpenSim Research and Development Manager. She did her doctoral work at Stanford University and is an expert in biomechanical simulation and using advanced mathematical techniques to understand human and animal movement. Many of you probably know Jen. She's been highly interactive with many of the folks using OpenSim, running the Visiting Scholars Program, workshops here at Stanford and around the world. And she has been a huge force in managing our team and getting to the point where we can introduce the 3.0 version of the software. So take it away, Jen.
All right. Thank you, Scott. So the goal of today's webinar is to introduce you to all of the new features we're rolling out with OpenSim 3.0. I'll start off with a few slides to give you an overview of what's new. Then I'll launch a live demo of OpenSim 3.0. But before I dive in, let me pause and review some of the big picture goals of the OpenSim project. As members of the biomechanics or rehabilitation research community, we all know that maintaining mobility is essential for health and happiness. We also know that understanding human movement is incredibly complex, so engineering simulations can help unravel this complexity. First, modeling and simulation allow us to visualize movement and the underlying muscle forces that drive those movements. For example, here's a simulation of an unexpected drop landing with and without an ankle brace. We'll explore this simulation in more detail later during the live demo. Simulations can also give us estimates of key variables like muscle forces and joint forces that are difficult or impossible to measure experimentally. For example, we can determine the muscle forces, joint forces, and contact forces during this drop landing. With simulations, we can also ask what-if questions. For example, what happens to the ankle during the landing if I make the ankle brace stiffer? We'll do this as well during the live demo. And then finally, by answering what-if questions, we can identify cause and effect relationships, one of the ultimate goals of biomechanics and rehabilitation research. So what is OpenSim? OpenSim is designed to enable modeling and simulation. It's freely available software with a set of tools for researchers who are studying the movement of humans and animals and robots. There are tools to model and visualize musculoskeletal structures. You can import experimental data and use it to scale your models. There are also general purpose inverse kinematics and inverse dynamics tools. And then you can generate muscle-driven simulations of movement and then run analyses and plot those results like these leg muscle activations shown here. Now, all of these tools are founded on principles from physics, physiology, and biology, and are built on top of a fast and open dynamics engine. So we believe that OpenSim is an incredibly powerful tool, but we're also continually working to improve the software. And these improvements are driven by our many and varied interactions with users like you. So we're up to 10,000 unique OpenSim software users, and we compile specific feature requests from those users. We can also now track our documentation, since it's online, to see which pages our users are visiting most often, and also what they're searching for. We also have an incredibly active user forum, which helps us to identify common stumbling blocks and common needs among our users. We interact with our users through webinars like this one, as well as our workshops for beginning to advanced users. We also see how new students react to OpenSim by using it in our introductory biomechanics course here at Stanford. We have visiting scholars. And then there's our internal team of postdocs, graduate students, and staff who not only develop the software, we also use it for our own research. Finally, we get regular feedback from our advisory board and funding officers. So in preparing for OpenSim 3.0, we collected insights and feedback from all of these interactions and used them to drive the new features and improvements that we've included in OpenSim 3.0. We hope that many of these insights will resonate with you as well as an OpenSim user. First, robust and accurate models of muscles are one of the core features that sets OpenSim apart from other similar software packages. Second, while OpenSim does have a big feature set, many researchers want to be able to extend and customize OpenSim. Third, many of the people who want to extend OpenSim and create custom workflows use Matlab or Python, not C++. Next, editing XML files we know is slow and tedious as a way to work with models. Fifth, it can be challenging for many users to get going with OpenSim, so we need to always explore ways to improve usability. Next, if you've generated great results with OpenSim, it's essential for you to be able to make movies to share your findings with the world and publish them and present them. And then finally, an inclusive and self-sustaining community of users is incredibly powerful. So in the slides that follow, I'll show how each one of these insights led to a new feature or improvement in OpenSim 3.0. But first, let me give you some quick background on OpenSim's structure before I dive into all of these changes in 3.0 and start throwing around terms like GUI and API and scripting. This figure shows the three main layers of the OpenSim software architecture. First, the applications, then the OpenSim API, and then the SimBody API. At the top level is the OpenSim GUI, or Graphical User Interface. This is a software application that you're probably most familiar with. Many of you may also be familiar with user-defined OpenSim plugins, and then with OpenSim 3.0, we've also added scripting interfaces in the GUI and in Matlab. All of these top-level applications use the same core library of tools for creating models and generating simulations, which we call the OpenSim API. API stands for Application Programming Interface. It includes, for example, the tools we use to define muscles, bodies, and joints, and then control them during a motion. The GUI uses all of these tools and wraps them in a nice user interface. If you know C++, you can write plugins that call these tools directly and create new muscles, new controllers, and more. Starting in 3.0, you can also call the API functions directly from a script in Matlab or the GUI. Then finally, at the foundation of OpenSim is SimBody. The OpenSim API uses the SimBody libraries, or API, for its dynamics engine. This means that we can call SimBody functions to do things like perform matrix operations and simulate contact forces, so that we don't have to reinvent the wheel in OpenSim. So one key part of the OpenSim libraries, or API, is its muscle models. This brings us to the first insight we collected from users. The core of OpenSim, and the feature that sets it apart from other biomechanics packages, is having accurate and robust models of muscle dynamics. These muscle models affect all users, whether it's at the API or the GUI. So in OpenSim 3.0, we've completely redesigned our muscle models and also added several new ones. we've improved the implementation of the core existing model in OpenSim, the Thalen model, ensuring it matches the papers on which it's based, and it's also robust during simulations from walking to upper extremity reaching. If you have models that currently use the Thalen muscle, for example, the gait models that we distribute, they'll be converted automatically to the new implementation of the Thalen muscle when you load your models in OpenSim 3.0. Matt Millard, who's a postdoc here at Stanford, also created new muscles that have improved performance in many scenarios and also more closely match the theory and experiments about how muscles work. One of these muscles, for example, the acceleration muscle, which is shown in red, has much better performance at low activation levels, as you can see by the count of integration steps, compared to the Thalen muscle. Now, I've just very briefly touched on these new and improved muscle models. You can watch a recording of Matt Millard's webinar to get some more information. Here's the instructions for how to find that webinar. So feedback also told us that many researchers want to be able to add new features and extend the capabilities of OpenSim. So we've made lots of improvements to the API over the past year to make it easier for developers to do this. I'll focus on just one area, the model component interface. So an OpenSim model is a collection of model components, including bodies and joints and muscles. So one of the core ways that people can extend OpenSim is by adding new model components. In 3.0, we have vastly improved the C++ interface that developers use to define model components and connect them to a model, so that now these developers can focus on the science and less on the bookkeeping complexities that come with C++. With the new interface, developers can now implement a model component over the course of days rather than weeks. For example, we've had users come to our workshops and implement a clutch spring or a muscle reflex controller over the course of 2 or 3 days. So with those slides, I touched on a couple of the key improvements to the OpenSim API. OpenSim 3.0 also has many improvements on the application or GUI side. First, since many users are more familiar with programming in Matlab or Python, we've added brand new scripting capabilities through a Matlab interface and a scripting shell in the GUI. We've also added live model editing in the GUI and implemented a host of usability improvements. We've also enhanced OpenSim's visualization capabilities, so you can make movies showing things like contact forces and joint reaction loads. And I think it's best to let these features all speak for themselves, so now let me demo 3.0 for you. So in this demo, we'll simulate landing from a drop of about 1/2 meter, where the muscles are driven by a simple stretch-based reflex controller. We'll look at whether adding an ankle brace might help prevent an ankle injury. So let me bring up OpenSim. I already have it running. The basic layout is pretty similar. We don't see anything too interesting yet because we haven't loaded any models or motions. Before I load my models, though, I need to load that plugin that defines the reflex controller. So this is the reflex controller that will activate muscles during a simulation when they're stretched. All right, so I have loaded the plugin successfully. Now let me open a model so we have something to look at here. So I can just find the folder where I have placed my model and locate it. First, I'll look at a model that has no brace or AFO. I can just drag it into the view window, and that should open up. All right, there we are. So we have loaded our model, and I can go to the navigator pane and see all of the model components, the bodies and joints and muscles that make up this model. And this model is very similar to the gait models that we distribute, but some of the researchers here, AJ Steff and Matt Demers, have added to this muscle. They've added a platform and contact points on the feet that will generate forces during the simulation, so the model doesn't fall through the floor. Now, I've already created one simulation of this drop landing from about 1/2 meter, and so I'll go ahead and load that. I can also drag and drop to load the motion. So now we see the model started at its initial pose. And I can just play the motion, and we see the model falls through the air, and then you see the muscles lighting up, indicating that they're being activated. So in this demo, we're interested in what happens to the ankle during the drop landing, in particular ankle inversion. So let's zoom in a little bit and try to see what's happening at the ankle. And it looks like there's a bit of inversion that's happening, but it's a little bit hard to see without plotting it. So let me bring up the OpenSim plotter. So it's empty. I have to add the X and Y variables. So on the Y-axis, I want to plot the ankle inversion angle. So that corresponds to the subtalar angle in this model. So I can enter the text that I'm looking for, and then I bring up everything that matches. We're going to focus on the right subtalar angle, so I'll select that. And I will just plot this as a function of time over the simulation. I'll go ahead and add that curve. I'll call this ankle inversion, since that's what we're looking at. Okay, so let's see. We start with a subtalar angle of 0, or an ankle inversion angle of 0, and then we get some inversion as the model falls through the air, and then we get a big peak of ankle inversion when the model and the foot hit the platform. And the peak of this is over 45 degrees. Now, the limit of the subtalar angle before we expect to see injury is 30 degrees. So it's pretty likely that this fall would do some damage to the ankle. So let's see what happens if we add an ankle brace. So AJ and Matt have also created a model that is similar in every other regard, but has a brace at the ankle, or an ankle-foot orthosis. I was working with this model earlier today, so I can find it in my list of recent files. So here is our model. Let me zoom out a little bit. So this model is exactly the same in every other regard, except it now has this ankle brace. The ankle brace is represented as two main pieces. There's a cuff that's attached to the tibia segment, and there's a foot plate with contact points again that connects to the cuff part. And between the cuff and the foot plate, there are connection points that you can see as little pink dots right there. And at these connection points, there's a linear bushing or spring that prevents the two segments of the AFO or ankle brace from coming apart, and thus helps prevent ankle inversion of the model. I can show you the bushing is just represented as an additional force in the model, along with a list of muscles. So now let's see what happens if we generate a new forward simulation. So rather than loading a motion this time, I'll generate a brand new forward simulation of the fall. Before I do that, my models are a little bit close together, so let me change the display. So if I right-click on the model name and go to Display and Model Offset, I can just move the model over a little bit in the X direction so their models are not so crowded. All right, so now let me bring up the forward tool so we can generate a new forward simulation with the added ankle brace. So here are the settings for the forward tool. I have the name of the model that I'm operating on. That's the landing model with the AFO or ankle brace. I can leave the controls blank because we're going to use that muscle reflex controller that was associated with the plugin. I can also leave the initial states blank because the forward simulation can just start from the current state of the model. I do want to check to solve for the equilibrium for actuator states, which will equilibrate the tendon and the muscle fibers at the start of the simulation. I'll shorten up the time range a little bit because we only need to go up to about 0.4 to get the full, to characterize the landing. I'll also go to my analyses pane. So if you remember earlier in my slides, I said that we added the ability to visualize things like contact forces and joint reaction forces. So let me add a force reporter analysis. Part of the force reporter analysis will output the simulated ground reaction force or contact force between the AFO footplate and the platform when it hits the ground. So I will add that analysis as well. We've made it easier to access the load and save settings features with each of the tools by putting them on their own button. So I want to make sure that I entered everything correctly. Since this is a live demo, I might have forgotten something. So I can load a settings file that I created earlier that will populate all the settings in the Forward Dynamics tool in case I forgot anything. I can also make a change and save a new settings file. Something we've also added in 3.0 is this context-sensitive help button. So say I didn't know what some of those inputs were, I had more questions about how Forward Dynamics works. I click Help, and this brings me to the live online version of the OpenSim help for the Forward Dynamics tool. And then I can continue and get more information about how Forward works and what all the inputs and outputs are. If you happen to be using OpenSim offline, you'll go automatically to a local version of that same user guide. I think I've entered everything correctly, so I will go ahead and hit Run. And we see the model falling through the air. As soon as I hit Run, I can go ahead and close the tool, and it'll keep running. All right, so we generated our forward simulation. It ran successfully. We can play it back. It looks like it might have improved the angle a little bit. It's a little hard to tell. But let me show you that visualization of the ground reaction force. So I'm just going to reposition it so we can actually see it, because it'll be underneath the platform once I load it. Okay, so I can go to, here's the results of that forward simulation that I just ran. I can right-click and select Associate Motion Data to associate additional motion information to display. And I can find that force reporter results. So here are my forward results from the run with the AFO model. And here's my file that has the output of the force reporter analysis. I'll open that. And then I just need to perform one quick setup step so that the GUI knows how to display the force reporter results. So I'll add a new motion object. I'll call it contact, or I could call it ground reaction force. I want to display this force at the center of mass of the AFO. So I'll select body force at center of mass. And then I just need to find the column in the force reporter file that corresponds to the force between the AFO footplate and the platform. And I'll select first the X, and then this is just the Y and the Z get populated automatically. And as I said before, I want to display this in the frame of the footplate. So I think that is all set. I can also load and save settings files for these additional motion objects. All right, so now when I, oops. Sorry about that, guys. We had a crash. I'm just reopening the model. Not sure what happened. This worked 100 times until I went live with it. That always happens. Okay. So I can reload the motion that I already generated. So there's the states. I'll reassociate the motion data. And redo that setup. Oh, I think I know what I did. Maybe. All right. I'm just redoing all of this setup. Sorry about that. Okay. All right. So now we have our contact force. So we see as the model lands on the platform, we get a vector that's the simulated ground reaction force. Now it's pretty big, so I might want to make it a little bit smaller, maybe half the size. And I can also change the color, so maybe I want it to be purple. I don't know why I would want to make it purple, but I'll do that. All right, so there is our ground reaction force drawn a little bit smaller. Okay, so I've shown you running the forward tool and how to associate new motion data with the motion. Now, I mentioned earlier, maybe we could explore making this ankle brace stiffer to see if we get even less ankle inversion. So I can do this with the new GUI-based property editor that we've added in OpenSim 3.0. So the property editor is in the bottom left panel, and I can select any body, say the torso, and I see a list of all of its properties. So it's a body, its mass center, and all of its inertial properties. And then I can click on any of those properties and add it. So say I wanted to add some mass to the torso to simulate having a backpack or something like that. I can also undo that change. I can also see, for example, all of the properties of the muscles. So maybe I was interested in seeing what would happen if I made one of the muscles really really strong. That's probably a little too strong, so I'll undo that as well. As I mentioned, what I'm really interested in is seeing what will happen if I make the brace stronger. So I can find the spring between the two parts of the foot plate, or the two parts of the AFO, and I can find the stiffness of that spring, and I could modify this. So I could go ahead and modify this and then rerun the forward simulation, but to save all of those steps and from having you guys have to watch all of those steps, I could also do it with a script. So one way to access the scripting is through this scripting shell. Oops, I do have to load the plugin. Okay. One way is just through the scripting shell. So I can create a variable that will and get the current model. And now I can print things about this model, like the number of bodies, for example. Oops, it's a function, so I have to add that. I could also get the number of joints. I just used the up arrow to bring up the last command that I entered. And now there are 15 joints in the model. So it's a lot of commands to run through the whole process of the generating the forward simulation, editing the model, and plotting the results. So I made a script that's already pre-canned, shown here. I'll go ahead and run that, and I'll explain a little bit about what's going on with the script while we're waiting. Okay, so here I'm performing that same call, getting a handle to the current model, and then oops, there's the results. I'll hide those, and then I'm editing the properties of the bushing, the medial part of the and lateral part of the bushing. I am running the forward tool. And then I'm plotting the results as well. And if we go back, we see the that there's an additional model in the View panel. And I'll also, just to prove to you the editing part worked, if I go and look at the bushing now, we see that the translational stiffness is now 100,000 instead of 10,000. And we also see the new simulation of the fall. Now, another really nice thing is that I auto-generated a new plot with our results. And what this shows is first the original fall that we looked at earlier, where there's no ankle brace. So that looks the same as before. We get that big peak in the subtalar ankle. And then we see the first brace, the softer brace, before I did some editing. And we see that it improves the position of the model as it falls through the air, but it doesn't really reduce the amount of inversion that happens after the model hits the platform. And then finally, we see with this stiff brace, it not only improves the position of the ankle during the fall, it also reduces the amount of inversion we see during impact. So this concludes the core part of the GUI demo. I'll just point out that we have many other scripts that we include as examples. So you can make a body segment heavier. There's a script to show you how to do some batch processing. Those will all be included with the release of OpenSim 3.0. And then there are similar example scripts for the Matlab interface. And you can get to help for all of those new scripting features from the help menu. With that, I'll go back to my slides. So our one quick final but very important insight from our users is that an open community of researchers and educators that supports itself is incredibly powerful. Our user base continues to grow, as you can see from this map. We just reached 10,000 unique users. We also see that researchers like you more and more are helping each other by answering questions on our user forum and freely sharing your models and simulations on simtk.org. In an effort to further promote sharing and transparency and even wider adoption of OpenSim, we've made some key changes to our licenses with 3.0. On the GUI or application side, now both academic and commercial use are allowed. When you use the GUI, whether it's to build models or generate simulations or just visualize results, you also must acknowledge that you used OpenSim by citing our paper from 2007. This allows us, as well as our funding agencies, to track how the software is being used, which is incredibly valuable. On the API side, the OpenSim C++ libraries now have a completely open source license. It's the Apache 2.0 license. You can get more details online about that license. As with the GUI, the API is open to any type of use, and it's still free. And we're also now distributing the source code for the API as a zip file so that anyone can review the code behind all the computations we perform in OpenSim. You can read more about each of these licenses on our website. I also want to quickly emphasize that you're still free to use any type of license or sharing scheme for your own models or plugins that you develop using OpenSim. For example, with most of the models we distribute with OpenSim, we use a Creative Commons license. So that brings us to the conclusion of the webinar, my presentation part anyways. I've touched on most of the key changes and improvements to OpenSim 3.0, but there are many more that I didn't have a chance to introduce. So please go to our website starting this afternoon and click on the download link to get a copy of OpenSim 3.0. We'll also resend you that link in a follow-up email to this webinar. You'll also find a full list of new features and updated documentation. I hope that this new software will accelerate both your teaching and research. Now, all of these improvements wouldn't be possible without the excellent 3.0 development team. Scott Delp, who is the moderator today, is the director of the NCSRR and the OpenSim project. Ayman Habib is the lead application architect, so on the GUI side. And then AJ Seth is the lead API architect. OpenSim also relies on the expertise of Michael Sherman, who's the chief SimBody architect. That's OpenSim's dynamics engine. Matt Demers, Sam Hamner, Tim Dorn and Matt Millard are several graduate students and postdocs whose efforts were essential to developing 3.0. And then Kevin Shu is a new software developer who's already made huge contributions to the software. Finally, OpenSim also relies on many other contributors and past developers. We encourage you to contribute as well so we can add your name to the list. And then finally, the OpenSim project is also grateful for funding from several agencies, including the NIH, the EU, and DARPA. With that, we can now move on to the Q&A section. As Scott mentioned earlier, the questions will be done through the Q&A panel. You can find that on your WebEx control, the WebEx control panel. So you just select all panelists and then type your question into the panel and hit send.
Great.
And we're now open for questions.
Yeah, thanks, Jen. Please do feel free to type in your question. I'm already getting some. These webinars are fun. I see people from all over the world. There are folks tuned in from the East Coast of the U.S., from Harvard and MIT. I see some Midwesterners from the Rehab Institute of Chicago. There are folks from California and San Diego, hi Deanna, UC Davis. There are people, several groups from Europe. It's quite late there, and also several from Japan and China. So that's got to be early in the morning there. So thanks everybody for tuning in. I'll just go ahead and ask Jen a couple questions. The first is, can I use the Matlab optimization toolbox now with OpenSim?
Yes, so you can integrate any of the, you can call any of the OpenSim API functions and also use the optimization toolbox at the same time. We're actually working on a version of our optimization example on the API side that's in C++, so it requires setting up a development environment and learning how to use C++. We're replicating that example to do the same thing in a Matlab script that calls one of the optimizers from the Matlab optimization toolbox.
Follow-on question, is the Matlab interface only for 32-bit Matlab, or will it work for 64-bit as well? The beta only worked on the 32-bit.
Yes, currently the Matlab scripting is for 32-bit, and you can install 32-bit Matlab on a 64-bit machine, but you do need the 32-bit Matlab.
The question's about, is there good documentation for the Matlab interface to the API available with the 3.0 release?
Yes, there's a chapter on scripting, and since this is a brand new feature, so the existing chapter has an overview of scripting in Matlab and scripting in the GUI. You can just bring that up by going to scripting help. So there's a scripting in the GUI page, a scripting with Matlab page, and then we've started to compile this common scripting commands. So it has some basic helpful commands, what are the add-on packages and libraries, and then additional commands. And we'll continue to add to this based on, and add new examples as well, based on your feedback.
Here's a question from Andrew. Do I now need Matlab to run OpenSim?
No, you can still use the OpenSim application as is. It's free, it doesn't rely on any other commercial packages. And you can use that scripting shell in the GUI to write Python scripts. And Python, you can again write scripts that access the OpenSim API. You don't have to set up a C++ development environment. And Python in general is a bit easier to learn than C++.
So there was a Python question too. Does OpenSim 3.0 allow scripting from Python, and is that possible from outside of OpenSim?
Yes, you can write from a Python or Jython shell as well. And if we find that a lot of people are doing that, we'll add some extra documentation to make that a little easier to get started.
Okay, let's see. Do I uninstall the previous version before installing 3.0?
You can, but it's not required. I have a couple different installations on my machine right now because when we're developing the new release, we make sure the results are comparable to what was happening in our past releases. So you can uninstall, or you can leave OpenSim 2.4, for example, installed.
So from Gina, will OpenSim 3.0 be available for the Mac OS?
So we currently, you can use the API on a Mac. Many people do that. You could also do the Matlab or Python scripting on a Mac. But this graphical user interface, you do need to have a Windows operating system. That being said, I gave this webinar on a Mac. I'm just using Boot Camp. So I have the Windows operating system also installed on my Mac. So that's one way to get around it.
From Daniel, is there full documentation on how the API is exposed to Matlab?
So the scripting documentation that's there is that page I showed earlier. And then to get additional documentation about the API, the best resource for that is to go to the Doxygen. And so this is where all of the OpenSim classes and functions that are part of those classes are defined. So that's the best resource to get more information about the API itself.
So Philippe asks, should OpenSim be running when doing scripting from another language like Matlab or Python?
No, you don't. The application doesn't have to be running. You have to do a quick setup step in Matlab, for example, to tell Matlab how to find the OpenSim core API libraries, and then it can find those automatically. That setup step is in scripting with Matlab. There's a getting started. So this is a quick one-time setup process.
Lots of great questions coming in from Andrew. Can OpenSim scripting control all of OpenSim's functions?
So there are some parts of the API that are not yet exposed to the API, so it has to go through a wrapping process so that scripting knows how to find it. And we've tried to expose most of the parts that we think users will need based on examples, and we've had quite a few people do beta testing and already use Matlab scripting for their research. So we've tried to expose as much as we think that you'll need. But if you do find something that is not exposed in the scripting, please let us know, post on the user forum, or send us an email.
This is from Filippo in Pisa, Italy, just getting started with OpenSim. He's searching for a model to simulate lifting and calculate loads on the lumbar spine. There is an excellent model of this spine that was developed at UC San Francisco and UC Berkeley that's available, but that model does not have arms. Could you suggest a model to use? So that's a good specific question that gets us to some improvements we've done in the model library and documenting the model library and trying to encourage people to submit their models. So Jen's going to the OpenSim musculoskeletal models of which ones are distributed and which other ones you can download. Let's see if we can find the spine model. Kat Steele put this together. If you're still watching the webinar, you can see Jen navigating. Now there is a model, full body model, that's available that does have arms that Sam Hamner developed. But Filippo, you're correct that the spine model doesn't have arms. So, and the model we have with arms doesn't have the detail of the spine. So it would be some work to combine those two models if you wanted to have a detailed spine model with arms. I'm sorry, I should have let Jen answer that.
You did an excellent job, Scott. Let me get a drink of water, so that's okay.
Question, Jen. Do you provide a debug mode when scripting?
Yes, you can change the level of debugging output that you get by going to Edit, and preferences, and you can change, excuse me, this number to get more debug messages. And if there's there's a syntax error, you'll see a little red caution. So sometimes you get direct feedback in the window. If there's another problem, a little red caution sign pops up in the bottom right, and you can get more information about the whatever was the issue.
Let's see. There are lots of questions. Some of them are quite detailed, and one of the things that we'll do following the webinar is we will post some of these questions to the OpenSim forum and give detailed answers there so that they're captured for everybody. They're excellent questions, and we would like to provide the answers to everybody. So keep them flowing in. We'll post them to the OpenSim user forum so that we can share the answers with everybody. But with that, I just wanted to thank everybody for participating, and thank Jen for putting this together, and the OpenSim team for getting this release together. You'll see it on the OpenSim website by the end of the day today. We'll investigate what happened with that crash and post the very latest version. We've done detailed testing over the last 2 months with lots of people hammering on the code to try to make it as robust as possible. But we certainly appreciate everyone's input. If you do find problems, please do bug reports, feature requests. We rely on your input to make the software better, so please do keep the questions and requests coming. So with that, I'll close the webinar and hope to see you all at a biomechanics conference sometime soon. Bye-bye.
Bye.